to Coffee Break, the live stream series brought to you by Microchip Technology, where our mission is to educate, entertain, and empower you to innovate in your designs. I'm your host, Dana Curtis, and you are watching Cocoa Break, our annual special to celebrate the season. As always, we're here to dive into the fascinating world of embedded control technologies, integrated circuits, and all things smart, connected, and secure. And about the time it takes to enjoy a fresh cup of cocoa. For those of you joining us for the first time, Cocoa Break is a live broadcast, and we encourage audience participation. But before I introduce our special guest, let's go over some quick housekeeping items. This is a live chat with a feed. Please type your questions into the chat feed, and one of our product review experts will look at your question and respond accordingly. And with that, let's get over to our very special guest joining us today. Jeff Kipe is a product marketing manager at Microchip Technology. Welcome, Jeff.
Thank you, Dana. Good to be here.
You're joining us today to talk about Microchip power energy metering solutions, which would be a normal topic that we have on a coffee break. But we have kind of a special backstory going on here.
Yeah, so this thing kind of coalesced nicely. Thanksgiving, I was at home with the family and got a call out of the blue from an old friend, Francesco. I think you may know him.
Yeah.
It went about like this.
Well, today we are at the Munich Christmas market, and as you can see around, things aren't quite bright as they should be. The problem is that we are running into some electrical problem issue. Oh, wait a second. I can call my buddy Jeff. Yeah.
So I picked up the phone. Wife wasn't particularly happy.
He's holding a
about
plug
that.
and he's got you on the phone.
Yeah, it was something like that. And it's not like I could come over there and help him fix it right there.
Right.
But I was able to point him in the right direction, which is get a smart meter to help diagnose what the problem is, and then you can figure out how to fix it once you know what the problem
let's
is.
dive into smart metering. So one thing that we were going to talk about is analog front ends, AFE. So why are Microchip's analog front ends so appropriate for metering?
Well, let's start with AFEs in general. The important thing about having an AFE in one of these systems is the things that you want to measure are out here in the real world. They're analog.
Right.
You want to take that over to the digital domain and do all the digital signal processing on it. So that's essentially what the AFEs do. The AFEs are able to interface with pretty much any current sensor, whether that's a shunt or a current transformer, a Rogowski coil, heck, a Hall effect sensor, any of those things. Takes the analog information in current form or voltage form and brings that over into the digital domain.
And we're assuming that there are specific standards that run?
There are specific standards, and those are largely applicable where you're doing billing, anything where you're charging a customer. The customer certainly doesn't want to get overcharged, and you know, there's regulatory things where that's imposed on the metering vendors externally. You've got a couple different standards that are primary there. In the European region, it's the IEC standard, the 62053. In the U.S., it's ANSI, and in other regions, they're really derivative off of those standards. Now,
One of those two.
yeah, one of those two is primary. The Microchip AFEs have been designed into systems that meet both of those standards, so we're capable of supporting that.
All right, so let's talk about fault detection.
So fault detection, you're measuring these things. You're measuring current, you're measuring voltage. If you've got multiple channels, you can measure both of those and calculate how much power you're consuming. That's pretty simple and straightforward for those engineers among us. We've even got temperature sensing on there, so you can track that. If you're going over temperature, then you can set an alarm for all of those things, whether it's over or under on current voltage and power, or whether you got too high a temperature. The fault detection lets the system know, hey, you got to do something, you got to do an interrupt, stop something to pull you back within range.
Okay, and then the 39F actually has an onboard calculation.
That's correct. We have two families of products, the 39F5 series and the 391 series. Okay. The 39F series has built on some metrology capability, so it will do some of the simple calculation for you, and it can be a much more efficient and effective approach.
Yeah, and then we'll get to other types of calculation a little bit later, right?
Yeah, we can talk about those later.
What kind of feature set are we looking at?
So the features are all really geared towards supporting that accuracy. You've got 24-bit delta sigma ADCs. You'll have one per channel, so you can measure those quantities at the same time. It's important to measure current and voltage at the same time if you're going to calculate power, because if you're measuring your current a little bit later than you're measuring your power, well, then the calculation isn't going to be quite right. And that kind of plays into the phase delay compensation as well. If you measure them both at the same time, but then in the signal chain, you end up with voltage coming in a little bit sooner than current, you end up messing it up a little bit. Your voltage reference, quality of your voltage reference is very important. If that drifts much over time, temperature, whatever, then you end up introducing some uncertainty there. Anything that might happen from channel to channel, whether it's digital offset, you can do that from one channel to the other. You've got calibration capability for that, or for the gain error that comes if you're using the gain capability in it. And then if you don't want all the channels, or if you only need one at a particular time, you can shut down a single channel. If you need to save power or control your heat, you can do that and just reset at any time. Even things like dithering, which isn't particularly a factor in smart metering, but dithering, which sounds like it's noise, and it really is in most cases. When you're talking about a delta sigma environment, introducing some known noise actually helps the delta sigma engine be more accurate at the end of the day.
Okay, so what about bad actors? What if the Grinch shows up, or Jack Skellington wants to disrupt the Christmas market?
Yeah, we got to save Christmas, right? So there are a couple of different elements on the safety side of things. One is to protect against the bad actors. That would be where you want to have a security key to make sure that there's nobody accessing the register map and mucking around with your settings that isn't supposed to be in there doing it. And then you can also have, we get a little clumsy at times, maybe a little too much eggnog during the holiday season.
As you
do. Yeah, me never, but I've heard that happening. So, if you end up sending something wrong, you've got a cyclical redundancy check that helps prevent that from happening. And again, all of these are geared towards accuracy. And the 39 series is capable of the best accuracy that is existent on the market right now, which is about 0.1% active power error over a 10,000 to 1 dynamic range.
Not bad. Is this only for smart meters?
No, it's not only for smart meters. The 39 series is automotive qualified, and there are instances, particularly as you get to more and more electric content in the vehicles, where power consumption, fuel gauge monitoring for your battery. Range anxiety is the big thing. One of the big things in the way of EV adoption. Knowing how many more miles you've got to go, how many more kilometers you've got to go is important. Okay. And then corollary to that, when you are running low, you want to get to a charging station. Again, you don't want to be overcharged. You don't want to pay for more than you're actually receiving. So for EV charging stations, AFEs and power monitoring systems are important and get used a lot. And it's not just billing accuracy there. I've got my own hybrid, and I've had a couple of instances where I'm plugged in and for some reason it's heating up too much. It's getting power too quickly, and that allows it to cut off.
Too much for the battery, right?
Yeah, saving the battery from damage, saving my car from fire or explosion. Nobody wants that, except maybe around the 4th of July.
Only on purpose.
Yeah, that's right. There's portable instrumentation. You're out in the field, kind of like Francesco was, and you want to be able to diagnose what's going on and understand whether it's a current, a voltage, or a power issue. And then, last one mentioned here is medical monitoring. You want your doctors working with the best information they can when they're diagnosing.
Yeah, you really have no room for error when you're talking about human life.
Yeah, it's vital.
Vital. So, do all of these solutions require the onboard calculation engine component?
They all require calculations.
Okay.
But we've got solutions in the 3910 series that rely entirely on external calculation engines. And in those that's often used where you want to do more than just those simple calculations that are capable on the 39F series are. So the 3910 series pairs very nicely with the PIC32 CX MTC. And not only does it pair well, customers can go off and do that themselves. We're building metrology libraries so that customers looking to implement this they have a packaged solution, but they can also just use it as a starting point and build in their own specifics and address things that way.
You got one of these systems over to Francesco?
Yeah, I did, as a matter of fact, and as I understand it, I don't like to brag, but I think I saved Christmas in Munich.
Well, he's a capable guy. I'm sure he'll figure it out just in time and have it all
he
wrapped
helped
up
a
with a
little
bow.
in there, I'll grant you that.
Thanks, Jeff.
Thank you,
Appreciate
Dana.
it.
Good being here.
That concludes our special edition of Coffee Break. As we wrap up season 14, we want to extend our heartfelt gratitude to everyone who made this season possible. A huge thank you to our incredible behind-the-scenes team, Dave, Matt, Tim, Jackson, Sean, Claudia, Maggie, Nicole, Michelle, Annette, Lisa, Megan, Sherlyn, Amanda, Diana, Marcy, Susan, Michael, and my superstar co-host, Aaliyah. Your hard work and dedication are the backbone of this show. Not to be excluded, we also want to express our appreciation to all of our subject matter experts, both in front of and behind the camera, for sharing their knowledge and insights with us as well. Most importantly, thank you to our amazing audience, you. Your support and enthusiasm drive everything we do here. As always, head over to microchip.com/coffee break, click on the subscribe button to get updates for all things Coffee Break, and keep an eye open for upcoming episodes of Season 15 coming in 2025. As we head into the holiday season, we wish you all a joyous and peaceful time filled with laughter and togetherness. May your holidays be bright and your new year be even brighter. We here at Microchip will be spending time with loved ones and expect to come back fresh and ready to empower your innovation in the new year. Until then, stay curious, stay creative, stay caffeinated.
Hi guys, we are in Munich live at the Christmas market. As you can see, we are at full power. Thanks to Microchip for the solution, and Jeff, the NCP391X family analog front end power meter did the trick. And we can all sit back and enjoy the lights now. Merry Christmas to everyone.